This is question 5. A U-tube manometer is connected to a closed tank as shown in figure 5. The air pressure in the tank is 120 Pascal. So we have a trapped air here with 120 Pascal, and the liquid in the tank is oil with gamma 12,000 here. So gamma here is the specific weight. So gamma here is equal to rho and G. The pressure at point A is 20 kilopascal, so we have point A here. Determine the depth of oil Z here and the differential reading H on the manometer. So in this question, we need to calculate what is the distance Z and distance H. So first, we could calculate the distance Z here, okay, because it is quite straightforward. So we have a point A here. So the pressure at point A is actually consists of the pressure of this height plus the pressure given from the air. So we could write this equation. We have a rho Gz plus pressure for air. From the question, we know the pressure of air, it is given as 120 Pascal. So, and then we could solve the calculation. So, the Z here is equal to 1.66 meters. Next, we need to calculate the height of H here. So, from the Pascal paradox line here, we could write P1 is equal to P2. So, and then we could calculate the pressure at point 1 as rho GH of this 0.7 meter height until this level, and then we add with the pressure at point number A here, because point A here is actually at the same level of this one. So and then we could calculate the pressure at point 2. So this pressure at point 2, it is straightforward. We could calculate as rho GH. So and then we add with the pressure at the surface. So this pressure is PATM. Okay, however, because the calculation is in pressure gauge, so means that the ATM is equal to 0. So we write our calculation like this. So and then we could determine the value of H is equal to 0.95 meter.